Well, how are you doing? Okay, this is going to be probably pretty controversial. No doubt our opposition are going to be very angry about this. I'm not sure what I'll title it. I might title it um, Blackpool Swan saving the best for last. That's what I might title it. Okay, our opposition like to equivocate between frontal perspective view where there is angular size change, and we also live within a density of air and temperature. So we have air and temperature changes, changing the density of things and moving things around visually. Um, and the thing about that is that changes our view of things all the time. Now, I have detailed before where when you're looking at the mountain behind Blackpool Tower, uh, what none of our opposition would take into account was optical drop, right? Where things drop in the distance. It's an optical thing, right? It happens. I've proven it, shown it, detailed it, demonstrated it, showed it in the real world, had got other people's data from their real world experiences of this. It's just a real thing. It's nothing to worry about. But our opposition are deadly scared of it, deadly afraid of it. They've all tried to debunk it. None of them could do it. But there's a second effect, and this one is like even Jose J.G. Gonzalez detailed this effect when he was laughing at this Blackpool Swan thing, and it's called visual occultation. And I've detailed this too, showed it, demonstrated it, showed it in the real world, blah blah blah. And the thing about it is our opposition like to ignore things that are reality because they need to keep an orthographic globe belief going because they're crazy. But the thing about it is you can't. Reality is reality, and people who won't deal with reality end up going crazy. That's what happens. So, in reality, optical drop and visual occultation are real effects. So, where do we go from there? Well, they like to put things into orthographic view, right? Because it suits them, because it takes away all perspective. Because the model, not their model, we own the globe model. That's a flat out model. But the model that they have hijacked from us, let's just say, that model, they always have to show you stuff in orthographic view. They can never show you anything in reality. Nothing is in frontal perspective view. It's always some screwed up view of reality. You know, some crazy screwed up view of reality. You know, they're going completely crazy at present. They really are under serious mental pressure. And the thing about it is they need to show you stuff in orthographic view for it to suit what they need it to suit. But then they also need to add in a huge amount of 7/6 of the radius refraction. You know, 7/6, or they have to add in as much of that as possible. And they need to add it in everywhere they can find. Even in orthographic view, they like to add it into orthographic view stuff. It's crazy. You don't add refraction into orthographic view. You don't add refraction into angular size changes. But seems as they constantly feel the need to do these things and mess around and equivocate between perspective view and orthographic view. Orthographic view and perspective view. They seem to constantly equivocate between the two of them. It's very sad. A very sad group of individuals. Majority of them, not some of them are okay, but that's a small group, small portion of the group, I should say. Most of them are very sad individuals, and they're basically like, if you imagine, everyone was on the Titanic, and a boat pulls up to say, "There's an iceberg coming. It's going to hit your boat. Get onto this boat, and this is a much better boat. You know, it's much more real. The boat you're on is not going to last. The iceberg is going to smash it, and the boat is going to go down, And no, they won't get on because they don't believe the iceberg exists, even though they're looking at it coming towards them. So I view them like people who might be passengers on the Titanic and won't get onto another boat. You know, not that the people on the Titanic had that option. I'm just saying, from a descriptive point of view, they won't get onto the other boat. You know what I mean? That the iceberg is not real. You know what I mean? It can't do anything. You know, as far as they're concerned. You know, and then they go down. The boat goes down. The iceberg hits the boat, and it goes down. This is what goes on with them. It's constant with them. They're very, very delusional people, and they always seem to come up with, like, they think they're so smart, and it's just like, my God, you know, they just constantly come up with things and try to attack us on stuff and get things wrong, and it's just, there's no humility. They never admit to being wrong. They just disappear and then turn back up some other time somewhere else. You know, it could be 10 minutes later on a different server or something. It's really pathetic. Like, most of them have no, and I mean majority of them have no humility. Even if you have humility with them, they show none with you. But that doesn't mean you shouldn't show humility. You should always show humility. But even if they don't. But this is what we're dealing with, right? So, I've done enough waffling on now for the moment. I'm just going to go through this, right? Here is an observer, 6 meters, right? I'm going to show, right, this observer, right, sorry, this observer is observing, I'll go out a bit, right, Blackpool Tower, and their line of sight, let's go right in, the line of sight is hitting the top of Blackpool Tower. They're not looking over it, they're hitting the top of Blackpool Tower, so they're not able to see. It's just under the top, I suppose, yeah. Just under the top. They're hitting the top. They can't see through that, let's just say, but they're just using that as their line of sight, right? So their line of sight is lower than Blackpool Tower, right? So then we come out to here. Sorry, I better scroll out and scroll back in because there's a, right? Now, just to show, right? Right. The distance to Dale Craig is 83,685.888 meters. Its size is 778 meters. It's actually less than that. It's not 778 meters. But I don't care. I just give it that for the moment. So that gives it a 0.53266 degree angular size. Right. The distance from the observer to the tower, to the tower, to the tower is 19,312.128 meters, and its size is 158 meters. The tower is actually slightly bigger, slightly higher than that. It's a few meters higher than that actually off of sea level, but it don't matter, right? Just give it that, right? And its angular size is 0.46876. So here we have, right, Dale Craig 0.53266 degrees, Blackpool Tower angular size 46876 degrees. So technically from here, now I've kind of given this a bit more. It's not as much as this. Like these two should be closer together. This triangle should be closer to this cross as far as angular size goes, because the difference in angular size between the two of them is 0.0639. So the resolution limit of the human eye is 0.02. So there's only a very small change in angular size between those two things. Right, so our opposition would have at one time tried to make it out as if there was this massive size. There isn't. There's a very, very small, very, very small amount of angular size change between the two of them, right? But that's not the point. The point is this, right? You saw where that angle line was going. It was below. Now this purple cross here, this is the exact same height as the tower. This is the height of the tower. And I've risen this up, this Dale Craig triangle up a little bit, right? To give it even a greater angular size. So if you were to do an angular size between this blue dot up to this cross, and this blue dot up to this triangle up here, then the angular size will be a lot greater for the up to the triangle than it is up to the purple cross. But see, the thing about it is this, right? I've extenuated it. I think that's the right way to describe it. I've extenuated it on purpose because here is the angle line, right? Here is your angle line. So you might have my cat in the background. She won't shut up. So here is the angle line, right? And that was going below. That was below the top of the tower. And the point I'm making is, if we take angular size change into account, right, the angle the viewer has going above the top of the tower, right? Because this angle line is not even above; it's below the top of the tower. So we're not bringing it even above the top of the tower. The angle line there, right, when it is intersecting underneath the top of the tower, it's still due to that angle line, that visual angle. Because that's the angle line from the person, the observer, right? With distance, it's going to appear to be way higher than the top of Dale Craig, with Dale Craig's angular size, because you have two different angular sizes. You have the angular size of the tower and angular size of Dale Craig, and even though Dale Craig is slightly more, it's the angle of the viewer's visual angle that is important, and that's what we're looking at here. So we have here is this is the line back would have intersected the tower at here, back where the tower was, and when it would have gotten to this is not orthographically, this is if we're taking it into account with some angular size change. When it would have got as far, when their angle line or their visual angle line would have gotten as far as the Dale Craig, it's way up in the sky, because there's an angle, because of the angular size changes, right? So we're not looking at things in reality with their actual sizes, because their actual sizes of Dale Craig is way huger than Blackpool Tower. I think it's 4.5 times or 4 times or something like that, 4.5 times the size of height of Blackpool Tower in its actual size, but its angular size, right, for the observer puts it a lot closer. So because Dale Craig in angular size is a lot closer in size than the Blackpool Tower, when the observer is looking at the top or even underneath the top, and especially over the top of Blackpool Tower, then they're looking way over the top of the size that they perceive Dale Craig to be. And I'm just going to show up here, right? Just going to come out of here, right? I've done this, right? So here is an observer, right? Now this observer is obviously a lot bigger in comparison in height. So they have a much greater observation height, right? And this, let's just say, is a tower, and this is a mountain, right? But these are angular sizes, right? So the observer is observing this here, this thing here, this purple line, and even though this purple line, right, is shorter in angular size than the red line here, it doesn't matter, because the observer views, when the observer is viewing this purple top of the purple line, or just below the top, the angle of view goes out for that observer due to the angular sizes of the objects. For the observer, the line of angle appears to go out over the top, because you're not viewing it in orthographic view where everything is actual sizes. You're viewing things. This is like using orthographic, but also adding in the factor of angular size. You're not viewing it in actual size. You're viewing things in angular size when you're front-on perspective. So what's happening is the line of sight is appearing to go above the mountain, when in reality it won't go. In reality, if the line of sight is below the top of the tower, it's going to meet the mountain. But because the line of sight, because of angular size changes, that doesn't happen. Because the distance involved, and it's going to give the impression that to the observer that they're looking up into the sky. So if we bring this closer, because in reality the whole Blackpool Tower would be closer, would be more this distance from the observer, and the mountain that distance from the observer. And remember, the observer is up way higher here than they would be normally. But I just bring the observer higher to bring down the kind of, just to extenuate the size, or to limit, or what's the word I'm looking for, to reverse the size, let's just say, of the two objects. So the whole point is that the observer views them smaller in angular size. And in reality, this is where Blackpool Tower is. So if we just close as far as proximity to the observer, it's more there, maybe even closer again. And so if we bring it up there, as if to the observer, this mountain here has this angular size. So to the observer is looking over the top of Blackpool Tower, or at the top of Blackpool Tower, and they're viewing the sky, because it's an angular. Because even though this is a greater angular size than the mountain, than the tower, the mountain here is a slightly greater angular size than the mountain. And even in this, I've extenuated. It wouldn't even be that much. Like down here, it wouldn't even be that much. It'd only be a small bit more in angular size. But I've extenuated it so for visual. But there you go. I mean, the observer is going to be appearing to be looking way over the top of Dale Craig, because they are not looking at Dale Craig in its actual size. The same way as they're not looking at the tower in its actual size. You know, that's just the way it is. It's just like, that's why you see what you see. Because you have to factor in visual occultation, which is what's happening here, right? Even though the mountain has a greater angular size than the tower, the fact that it's back behind and the observer's line of sight is dealing with the tower in front of them, because the tower has a greater height to it, even though its angular size is slightly smaller, the angle of view that the observer has to take gives the impression that they're looking way over the top of the mountain. And they are, because they're looking up into the sky, because they can't, it doesn't make any, it's not a natural thing to try and put your eye line where it should be, or where you think it should be. You're just going to look where you think, put your eye line where it should be. For precision, you don't do that. You put your eye line where you think it should be. You know, whatever appears aesthetic to you or whatever. That's what you do. So just going to show here before I finish. So here is, I've moved back this canister here, slightly back from this. Now, technically this still has, right, this red and chrome canister, this still has a greater angular size than this pepper container here. But the angle, if I'm looking up here, right, if I'm the observer and I'm looking up here, I'm not seeing this. And if I move, I'm not seeing this. Even though its angular size is still slightly bigger, I'm not seeing this. You know, I'm looking up here. That's what I'm seeing. I'm seeing up here. Because my view, because of how I have to view and how perspective works, as far as I'm concerned, I'm looking up here at this light, up in the light. I'm not seeing this at all. So if I just go back, so this is visual occultation. So about there, I'm still not seeing, only maybe the very top of that container. But if I could hold that same angular size but move it straight back, right, I wouldn't be able to see it due to the angle, because the angle is changing it. So like, I'll move it, leave it, go back a little bit more, right? Now, if I go back a bit more, now, even if I move it, even if I could make it out this height, I still won't see it back there. My angle doesn't allow it to happen. It's about my angle of view, my viewing angle. That's what it's about. And that's why we see things the way we see. And that's why we see what we see in the Blackpool photo. You know, and that's not even adding in optical drop into this, although it is an optical drop. It's basically the reason why we see that. It's part of visual occultation. But visual occultation is basically something that's higher than the observer in front of them, causing something that's much higher than that behind them appearing to be lower due to distance. But as you can see, this is a totally flat table. There's a few pieces of pepper or something come out, or a plant I moved or something there. But it's a totally flat table. You can see, obviously, this was smaller than that. You know, but you see that in every city. Every city you go to, you see buildings that are smaller than other buildings, or sorry, bigger than other buildings, but they appear smaller from the observer's point of view. That's all it is, you know. So that's all that's going on. It's an angular size. The angular size change, yeah, but it's also distance. You know, like as I said, if you could hold the same angular size but bring it straight back, you're still not going to see it because you're looking up here. that's where you're looking. You're not going to see it because the angular size is a linear thing then at that stage. You're looking up here. I mean, no, I have no doubt that our opposition are going to, they're going to be in a rage over this. I'm going to say, you can't do this and you can't do that. You can't do anything. You can only do what they want you to do that proves to them that our globe is true. But it's not even their globe, it's our globe. Because, it's built off a flat earth. They're always in a rage over something, aren't they? They always have in a rage, and they're always like trolling, and they're always wanting to have a big maths argument. It's like there's no reality goes on with these people. Like I've not seen any of them show this effect. Never in 7 years, not one of them has addressed this effect. Not one of them. Out of God knows how many that have gone through, not one of them has addressed it. Not one in all those years. And this effect I've been talking about since 2017, thanks to India. This effect here, and not one of them have addressed it. That's 5 years now. Not one of them will talk about it. Why won't you talk about that effect? Why will you not talk about that? Something we see all the time. You go outside your house and see something that's higher in your house, behind your house, but because of where you are, it appears to be lower. That's all it is. It's just a perspective issue. But obviously, you can't address this effect because it absolutely destroys your pathetic world. That's what's going on. Your world is pathetic. The world you live in is pathetic. What you believe is pathetic. There's no other word for it anymore. I mean, how you can keep believing such complete and utter super nonsense, I don't know. But if you're going to be in the comments and you're a flat earther, prepare to see probably the great 2022 Easter Sunday troll attack, because no doubt I'm going to have all the idiots in there telling me about everything and you don't know, and let's have a maths argument, let's talk about maths and have a maths argument instead of dealing with reality. Let's not deal with reality ever. Let's always have a maths argument. Let's come up with some other nonsense. Let's view everything in orthographic view and make it all really wooden. And then a load of 7/6 over fraction that we don't have a radius for, and make it look like it would fit a globe. Instead of dealing with the fact that in reality, adding in angular size change. Or curvature, you know what I mean? Absolutely destroy them, as I showed in the debate with Randy. They just don't have anything. We're just absolutely bossing this argument. Like, they don't have anything. They don't, and they're not going to have. It's over. It's over. Stay on the Titanic if you want to. Stay on it. Stay on it. Your own little globe Titanic. Stay on it. That iceberg is it's on the way. Like, there's no stopping it. You had your chance to get off. Stay on it. You deserve what you get. See ya.